So let's get started. Welcome everyone, Wanyanelum, as we like to say here on the Sunshine Coast, to the Coast to Corals online edition, hosted by Reef Check Australia. So before we begin, I would like to acknowledge the country that we live, work, and play on. For me, that's the Gubbi Gubbi and Yinabara people. Today I was out west, all the way out in Kilcoy, which is Yinabara, a very beautiful area. Just pay my respects to their elders past, present, and emerging. So thank you everyone for attending tonight. We have the wonderful PhD candidate, Maddison Brown, presenting on restoration opportunities in a UNESCO Biosphere for the Coast to Corals seminar series, I guess you could call it. So a brief introduction for those who don't know who Reef Check Australia is. We're an NGO that believes in protecting reefs, oceans, and doing this through empowering people through hands-on research and education. So we train scuba divers like this person here, who might just have a recreational interest in going diving, to perform scientific research to collect large data sets on baseline health for coral reefs. And we also then engage people who might not be interested in scuba diving, but just education and outreach and conservation to do community engagement events like this one. So a little bit of online housekeeping. I did mention before, but for those who missed, this is being recorded at the moment. So if you're not comfortable with your name or your face at any given time, usually we take a selfie at the end, please do let me know, or just don't turn your camera on at the end. Please also make sure that your video and microphone is muted throughout the talk, unless you have a question for Maddie. If you aren't on our mailing list, Julie does a wonderful job at sending out a monthly mail about Reef Check Australia and all our activities in the region. So that's the email to sign up to it. You're welcome to use the chat box if you have a question in Zoom land. You can also, let me see if I can do it here. You can raise your hand. So there are hand gestures. Yeah, there we go. Maddie's done it. And that's a polite way of just butting in. Or you can just butt in with your microphone as well. So I do want to talk quickly about a couple upcoming events in the Sunshine Coast region. We have a plastic-free sea festival on at Happy Valley, which is in Caloundra, from 8 a.m. to 11 a.m. It's hosted by the amazing visionary Ocean Warrior, and backed up by Sunshine Coast Council, and we will be there. It's on Saturday, the 23rd of September, so just in a couple weekends' time. So Reef Check Australia will be at Your Mate's Brewery, not the one up in Karoi, but their first brewery. I need to change this to add a name, down in Warana. On Sunday, the 24th of September, just hosting a raffle. So we will be raffling out some prizes donated by Your Mate's Brewery to raise money for Reef Check. And you will also see my lovely face at Caloundra Music Festival. So if by the end of the evening you're tired of looking at it, don't come and annoy me at Caloundra Music Festival. But that's on Friday, the 29th till the 1st of October. And we'll have some pretty cool activities there for you guys to do. We'll have a green screen set up with some pledges there and a lot of educational materials around conservation that we do regionally, really. And next month's event is on, excuse me, rubble stabilization and dynamics by Tanya Kenning. And that's on Tuesday, October the 3rd, at the same time, 6:30 p.m. And there is also a seagrass restoration event happening, which is also coming up pretty quickly on Saturday, the 21st of October. So USC Seaweed Research Group, which Maddie also has done a little bit of research in, amazing, is hosting a community engagement event there where they'll be talking everything and anything about seaweed. And I highly recommend getting down there if you do have a free day. They're a very great multidisciplinary research group. So they do everything from aquaculture to hardcore marine science to nutrition and dietetics, all on different types of seaweed and how it can help save the planet, really. So I'll be there as well if you want to get on down there. If you are interested in coming to any of these events with me and any of our other amazing volunteers, or you're a scuba diver and you want to learn how to perform scientific surveys underwater, please do get in touch, either going on our website, which is just down there, but even sending us a message. We're on any of the social medias, and we will reply and let you know how that's possible, really. And these are the social medias, as I was just mentioning: Instagram, Twitter, LinkedIn, and Facebook. And if you just look up Reef Check Australia, you should be able to find us. I do also want to thank the plethora of sponsors that we do have at Reef Check Australia. This is only just a couple of them that we collaborate with and that help us. Reef Check Australia is a non-for-profit, which means that we do not make money. We do not generate profits, really. It's in the name, just for the fun of it, which means it's quite hard to come by money to perform our research and to perform our community engagement and citizen science activities. And it wouldn't be possible without the endorsement of amazing companies and local LGA, people like Sunshine Coast Council, Gold Coast Council, and the GPR Foundation as well. And obviously as well, thank you to our amazing volunteers. Here are just some of them. Julie, who was on tonight, Illa, who's been running the Coastal Corals Seminar this entire year, who is amazing, and our General Manager, Jody, who steers the ship and is doing an amazing job at it as well. It truly does take a village, and without the collaborative effort of volunteers and a little bit of paid employees, Reef Check Australia wouldn't exist. It would cease to exist. So a massive and huge thank you always to everyone and their hard work behind the scenes for making it happen. And now on to tonight's speaker. Do you want me to read this out, Maddie, or do you want to introduce yourself?
I can introduce it myself.
Yeah, okay, wonderful.
Yeah, thank you for the intro, Pablo, and thank you everyone for chiming into this online session. So my name is Maddison Brown and I'm a marine ecologist. I previously worked for the Noosa Oyster Reef Restoration Project, where I was helping out with community engagement, education, and a lot of the field work associated with that project. I also previously was working at the University of Sunshine Coast, where I did some seaweed research, and now I'm at UQ. So I want to show you a bit about my research. So I will share you through my screen and get started. All right. So let's dive straight in. How does that look? Is that okay for everyone?
That's
Yeah.
correct.
Okay, thank you. So I should also mention to everyone participating, please don't be shy if you would like to chime in with a question, or you can raise your hand or anything. Understand that there are so many different research projects and there's so much different terminology and things can be hard to understand. So if you want to chime in at any time, please don't be afraid. Otherwise, you can ask questions at the end. So today I will be presenting some of the research I have been conducting in Noosa, which is a UNESCO Biosphere Reserve. And I'm looking into the potential for coastal wetland restoration. My supervisors are Dr. Catherine Lovelock, Dr. Valerie Hagar, and Dr. Megan Saunders. And so it's really, really cool to be a part of this research team. Just to build on Pablo's previous acknowledgement of country, I would like to acknowledge the Kabi Kabi and Jinnabara First Nations people as the traditional custodians of the land on which this study is conducted. So here in this map here, we can see the boundaries of the Kabi Kabi people, which extend far beyond this small study region here, which is the Noosa Shire Council, which is where this study is being conducted. So just zooming in here, my study site is the Noosa Shire, which is one big catchment. And the catchment consists of multiple subcatchments. And these subcatchments mean that it is an area of land where the water collects when it rains, often bounded by hills. And as the water flows over the landscape, it finds its way into streams and down into the soil and feeds into the river. And this is why Noosa is classified as an estuarine area, because it has that freshwater and that saltwater influence. Estuarine areas support seagrass, intertidal flats, mangroves, and salt marsh ecosystems, which makes this particular location really unique. These habitats provide space for migratory birds, fishery species, including crustaceans and fish, turtles, dolphins, and many other species. And Noosa is also unique because it is north-facing. This is the Noosa headland here. I hope you can see my cursor. So here is the river mouth of the Noosa estuary. When the tide comes up, the salt water rushes in through this narrow passageway, which also provides nutrients for the rest of the catchment. Also, when it rains, all the fresh water comes up from these kind of high elevation points and flows all the way down the river, which also provides nutrients for a very biodiverse ecosystem, which makes Noosa a really special study site. Noosa is considered to be different by nature, considering the Noosa Biosphere Reserve is one of the first in Queensland. A biosphere reserve is classified as a place that demonstrates innovative approaches to conservation and sustainable development. And Noosa really goes beyond confined protected areas where sustainable economic development is made possible through partnerships with the community. So the Noosa Biosphere Reserve has a rich biodiversity, including more than 300 bird species, 60 distinct ecosystems, and approximately 1,300 plant species. So in these pictures here, you can see that Noosa is used as a recreational reserve. We also have the Noosa headland, which is a mecca for surfing, boating. It's a very unique place because we've got that urban development, but also this really special river mouth and surrounding mangroves, which make Noosa a little bit vulnerable to certain coastal hazards, which we'll talk about later in my presentation. So Noosa was also one of the first local governments in Queensland to declare a climate emergency in 2019. Noosa is actually very low and is very sensitive to sea level rise, and the development cannot undertake the natural environment. So that means that the environment is embedded into the planning scheme. 42% of the Shire is protected as either national park, environment reserve, or a conservation area. And this is very unique considering to compare the rest of the state, which is only 9% is protected. And the catchment contains the Kalula National Park, which is here. And this mainly contains coastal heathland vegetation and salty vegetation and sandy soil. So you might know that this is Noosa North Shore and Tiwa. And then down here, we have a lot more of those kind of mangrove habitats and Melaleuca. So here's a picture of the Melaleucas, which is the paperbark forests, which are seasonally inundated with water. And they're also called supratidal forests, which means that they're above the tide. However, as we will be talking about soon with sea level rise, these above tidal forests might be actually in the tide. Noosa has a very strong community support for conservation and nature-based solutions. And in a recent livability survey, they found that elements of natural environment and protection of the natural environment were selected as two of the strongest contributors to local livability. So people in Noosa really want to live there because of the natural assets and the natural beauty. So therefore, the Noosa Council have a strong push and pressure to preserve these natural wonders. Noosa is a low-lying floodplain, and a lot of the vegetation that used to exist before we colonized the area was Melaleuca and mangroves and a lot of coastal wetlands. However, a lot of this land has been cleared, which has meant that a lot of the land here that we have built upon is vulnerable to inundation, which means flooding, as a result of sea level rise. So therefore, Noosa is building a coastal hazards adaptation plan, and they also have goals to reach. So they want to reach net zero emissions targets by 2026 to mitigate the Noosa Council's impact on climate change. And also they were really interested in collaborating with researchers like my team to look at evidence and values-based framework to look into how can we restore these coastal ecosystems. So next, I'm just going to quickly outline what does restoration really mean. So restoration means kind of returning back what we've lost, simply put. And this can involve many different processes. And this is just a little bit of a very vague outline. So it can involve planting and seeding. It can involve habitat enhancement. And here is a picture of where they inserted rubble and rocks to create the foundations of the Noosa oyster reefs. They can also this restoration can also include introduction of fish and wildlife to supplement the population. And also community support and engagement is really important in order for restoration to be successful. I put in this little picture here because when I think of restoration, sometimes people don't really understand what that means, but I always think of it as rewilding. So a quote from David Attenborough, he says, "We must rewild the world. It is easier than you think. A century from now, our planet could be a wild place again." So unfortunately, because of our development, we have created fewer and fewer spaces for natural vegetation, natural ecosystems to exist. Therefore, we need to artificially, in a way, return these ecosystems back to their former glory. And here comes my research. So I'm looking into what is the potential for coastal wetland restoration in Noosa. I want to know what land uses reside on these sites and what kind of vegetation will transition if we restore, what species will benefit from this new habitat, and what is the carbon abatement potential of these sites. So if that's to kind of introduce you to the carbon aspect of this project, we're looking into how much carbon can these ecosystems store. So plants photosynthesize, which means that when they deposit their organic matter, which is their leaves and their trunk, whenever that decomposes, that is essentially carbon. And then if that is stored under the layers and layers of soil, then that carbon then becomes sequestered, which means that it will be stored for a long period of time. And so we're looking at how can these ecosystems actually help mitigate climate change through their ecosystem services, one of which is carbon sequestration. So please chime in if there's any questions there. So historically, most of Noosa catchment was covered by eucalyptus-dominated communities, rainforest here, and scrub. Melaleuca woodland is all here. And other coastal communities, including heath, which is kind of like shrubland, and mangroves and salt marsh. These different vegetation types combine to make up the pre-clearing vegetation of the Noosa catchment. So this is kind of the estimation of what the vegetation looked like before we cleared it. So I'm looking at a lot of this kind of mapping to predict where restoration could happen, because we want to conduct restoration in places where the restoration will be successful. Therefore, if we restore a parcel of land, we want it to return back to what it used to be. So I'm looking at a lot of these mapping to find sites. Next, I'm also using digital elevation and sea level rise predictions to look at how much of this land is going to be inundated and flooded in the future. I'm also looking at what are the different land uses suitable for restoration. So it might be like, residential land, it might already be conservation and it might be degraded in some way, or farmland. So these are all of the land uses that are suitable for restoration. And then I'm looking at, are the sites large enough to be restored? Because if you think of like economies of scale, it wouldn't be worth it to restore a small parcel of land. We want to restore as much land as possible in order for it to actually provide the services that we need, which include, habitat, carbon sequestration, coastal protection, and mitigating wave energy and erosion. So these are the kind of ecosystems that I'm looking out for in the mapping. So these are the mangroves. This is the salt marsh, which is like behind the mangroves. And then these are the forests that are seasonally inundated, which means that a few months of the year, they're underwater. And this are the Melaleuca and open woodland vegetation. I'm also looking at sea level rise and storm tides. And I'm looking at where, worst case scenario, where is the water going to go? Because if the water goes up if the water will cover a parcel of land, then it can be therefore lodged as a restoration project, because here we're looking for land that will be underwater, that can underwater as the tides come in and out. Therefore, we can restore those mangroves. I hope that makes sense. So in this table here, it shows the meters in which the tide is expected to rise to. So in roughly, oh gosh, like 10 to 20 years, the sea level will rise 0.2 of a meter. And then at the end of the century, at worst case scenario, it'll rise to 0.8 meters. Yes. Does anyone want?
Question.
Yes, yeah, of course.
Sorry.
Yeah. Don't be sorry.
Interesting. Why did you choose RCP 8.5? And are you going to use other predictions of the IPCC as well to see how that varies, or are you just sticking to worst case scenario?
We chose worst case scenario because that will show the maximum land that is actually available for restoration. We want to look at bordering habitats to ensure connectivity. So if we're restoring mangrove habitat, then behind it, we would hope that it would be a conservation area. So then that connectivity can facilitate the restoration project. And yeah, we chose worst case scenario because that will show us the maximum amount of land that's available for us to restore.
Yeah, very cool.
Yeah. Okay. Hopefully that answers your question.
That does. Nice.
Okay. Thank you. So, yeah, as Pablo's mentioned, so the Intergovernmental Panel on Climate Change, IPCC, projects global mean sea level by summing up the contributions from physical processes to provide a probability of sea level rise. And here I've chosen RCP 8.5, which is representative concentration pathway, which is the concentration of greenhouse gases that will contribute to melting of ice caps and glaciers, which will cause sea level rise. Right, so moving on. How do I do that? There we go. Okay, so look, here are some of my preliminary results. I have located 62.5 hectares of land that could be restored back to its former glory. And these areas are not currently wetlands, but they can be restored back to what they used to be, which are wetlands. They are usually grazed lands, like for farming, below the highest astronomical tide mark, and were coastal forests in the past. And here I'm overlapping the restoration areas with other information as well in order to learn more about these sites. These sites contain various current land uses, which means that the Noosa Council will decide based on these sites, you know, what they will restore. And all of these different land uses create different barriers to restore. So here we might need to convert farmland back into wetland. Here is some residential properties. So there's so many barriers of entry here, and this is just research, so not necessarily we're not in the planning stages, but here's just showing the potential for restoration. We also have parcels of land that are already national park. We have some conservation land and parcels of land that include mining as well. Just going to take a sip of water. My throat's getting dry.
Can I ask what mining is being conducted in Noosa?
What was that, sorry?
Can I ask what mining is being conducted in Noosa?
I know, I saw that too. There's actually 2 quarries in Noosa, and I really probably shouldn't guess, but based on aerial imagery, I think that it must be some sort of like sedimentary mining, whether it be like shells or or salt. They're quarries. And yeah, I can show you on an aerial imagery, but I had no idea that there was a mine. There's 2 quarries in Noosa. Didn't know about them. We should return them back to forests. Okay, so here is the vegetation that is assumed to transition to if we restored these sites. So here is just some pictures to show on what these ecosystems look like. We found 2.6 hectares of eucalyptus woodlands, and most of the hectares that are available to be restored is Melaleuca. And this just shows the extent of all the different types of coastal wetlands that could be restored. Yes. So heath, I think I wrote here, heathland is essentially treeless plant communities dominated by low shrubs and various other ground flora, where soils are subjected to prolonged periods of high soil moisture. So they're a wetter type of vegetation. And they're found in low-lying and typically coastal and subcoastal situations. These wetter forms of heaths are typically termed wet heaths or coastal and subcoastal wet heath swamps. So as you probably know, these ecosystems are often undervalued, considering they're not the most accessible places, but they have incredible ecosystem services and also importance. So this is just some preliminary data into the potential carbon abatement of these sites. And so these figures are the CO2 equivalent metric, which is CO2 equivalent in megatons over 25 years, which is the first value, and over 100 years, that's the amount of carbon that could be stored in the soils. So then I looked into weighing up the co-benefits of these blue carbon ecosystems in the Noosa region. So co-benefits are quantifiable and scientifically defensible positive outcomes likely to accompany the delivery of a restoration project. So in some cases, these co-benefits can be financially incentivized to create value when selling carbon credits. So you can sell carbon credits and make a profit of the plants and the vegetation that you restore. There are also some other potential co-benefits, which include biodiversity. And so the restoration of wetland areas provides habitat for many species, and including fish. It improves the waterways' health and improves coastal near-shore zones through improved processing of nutrient runoff. So there's so many ways that these coastal wetlands benefit our waterways. So I'm looking at which sites have more co-benefits than others, for example. So the first metric we looked into was the richness of ENVT taxa, which stands for endangered, vulnerable, near threatened or extinct species. And this means that what was the species richness? So the biodiversity of these sites. So you can see that site number 3 stands out with the high species richness, which is this site here. So it goes 1, 2, and then 3, which is a high species richness. And this has to be taken with a grain of salt, considering this is a very, I guess, like busy location, which means that maybe there's just been more surveys done compared to up here, which is more remote and therefore a low survey effort. So yeah, it could be just a bias, considering that there is more species richness down here compared to up here. Then I looked into the 9 leucinine threatened fauna species. So the leucinine are the 9 like shortlisted, not the shortlisted, sorry, the decided 9 species that they want to prioritize to protect. And then I looked at the sites, and I looked at whether these particular species were either present, yes or no, in the sites. Then I looked at, is the suitable habitat low, medium, or high if it was to be restored, and the likelihood of restoration having a positive impact. So looking here at the RE, which is the regional ecosystem, that will be returned upon restoration. So as you can see, some species benefit, have a high positive impact or a low impact. So here's just a snapshot into a few of the species that I looked into based on the restoration sites that I located. So here we have the water mouse, and a water mouse is an endangered species that often is found in mangrove ecosystems. The yellow dots here are the sightings of these this particular species, and we found that site 5 will most benefit this species. But also, we acknowledge the surveying bias that could kind of sway the data a little bit. Also, what's special about this site here compared to up here is down here, there's a lot more mangroves, which provide a lot of coastal protection for floods, and also mangroves are most efficient at storing carbon. Then we looked at restoring black glossy habitat, cockatoo habitat. And we found that the 4 regional ecosystems with high proportion of primary food trees within and around the sites include 1 and 6. So 1 down up here is actually the land in which you would expect glossy habitats to reside, because this is the habitat that they use for feeding. However, a lot of their sightings are down here, and this means that there's been a lot of good citizen science records for black glossy habitat down here. So yeah, just weighing up the pros and cons of like each species, and looking into the next species is the Wallam rocket frog. It's a ground-dwelling frog that breeds in temporary or permanent still water. It is known as an acid frog and is one of the several frogs in southeast Queensland and New South Wales that undergo tadpole development in soft waters of high acidity and low nutrient content. And recent records indicate that this species still occurs through its previous range, but has suffered from habitat loss and disturbance. And you can see that this particular site here, there has been some records of this particular frog, which means that restoring this habitat here could benefit this frog. Now looking at koalas. So lots of the regional ecosystems with preferred food species in buffers of the sites, and some of the sites have potential to restore those ecosystems if the tidal inundation doesn't compromise the survival of eucalyptus species. So we're looking at the trade-offs between these different species. And as you can imagine, sea level rise will not benefit terrestrial species like koalas. So that's why we're looking at the connectivity of forest to tidal forest. So looking at whether restoration of these ecosystems will benefit or be a detriment to these endangered species. So finally, we also are looking into the native tidal and also engagement with the Kabi Kabi people in order to collaborate with them on potential blue carbon restoration projects. So we've discussed native tidal and current projected Indigenous land use agreements. And once we have shortlisted profitable sites, NUSA may engage with the Kabi Kabi people to undertake a cultural heritage survey of the sites. And then that will also be a part of that cost-benefit analysis to weigh up the pros and the cons of which sites to restore. So that is pretty much me. I hope that that was a good introduction to coastal wetlands. And thank you so much for your time. Does anyone have any questions?
Thank you, Maddie. That was amazing.
Yeah, thanks, Maddison. Thought that was really great.
Thank you.
Yeah, I guess I was thinking from a point of view, so I'm working with Healthy Land and Water, and we have put in for a grant with the federal government, and previously I was working on the Moreton Bay Ramsar wetland, just focused on that. So I've been here just a year now, and we've put in to continue working in the Moreton Bay Ramsar wetland, but there's similar themes that we would be interested in working on as well, like such as an evidence-based framework. I think you mentioned on highlighting coastal ecosystems or future restoration sites and whatnot. Yeah, I'd just like to flag that there probably or potentially could be future collaboration opportunities there.
Yeah.
Yeah, we've just got to watch this space and see how that grant opportunity pulls through. And then if we are awarded it through the National Land Care Partnership, then we'll have to go through a co-design with the federal government. So we're certainly fighting to continue doing work in the Moreton Bay Ramsar wetland, but I guess it just depends on their priorities. And then it'll have to be EPBC focused as well. So yeah, whether they're threatened ecological communities or there's there's a crossover in the Noosa 9 species as well there, with some of those would be EPBC listed as well.
Yeah. So your work, is that particularly in restoration?
It's really, really variable. I'm still learning the ropes at Healthy Land and Water, but yeah, I think we did coastal restoration over like 200 hectares over the last 5 years of this project. But you can also, we collaborate with people and fill in the gaps, knowledge gaps. So like water mouse is probably one of those species where we would be interested in working with probably DES for the conservation park, where they have old data and kabi. Yeah, so we can do, I'm on the biodiversity conservation team, so that's pretty broad. And we can work with councils on developing frameworks. We've gotten together a stakeholder network for Moreton Bay Ramsar wetland and the shellfish reef restoration as well. So I know we're quite interested in seagrass restoration, and if there's seaweed restoration, we've dabbled a little bit in the shellfish reef restoration with Ozfish and UniSC as well. So with Ben Gilby, but not really a limit, really, as long as the feds are pretty happy with what we're prioritizing for the region.
Yeah, that's actually really interesting, because I think one of my chapters I'm really considering multi-habitat restoration and combining multiple habitats together that facilitate each other for restoration. So whether it be, seagrass, oyster reefs, mangroves, looking into that as well. And I actually do work with Healthy Land and Water as well with this project. So yeah.
Which team is this?
Yeah. I think they've just been supplying us with data, but I don't actually know which team they're on.
Okay. Is it the the waterways monitoring data or catchment?
I think that it was been more water quality stuff.
Yeah, okay. Yeah, so probably our knowledge research team.
Yeah, but I can also have a look, email you or something, and put all the pieces of the puzzle together.
Yeah, absolutely. I think that'd be a great idea.
Yeah.
Did you have access to my email, or should I just pop it in the chat?
Put in the chat. Or I can put my email in the chat, whatever works.
I'll add it in.
Okay.
Thank you.
Thank you. Thanks for introducing yourself as well.
No worries.
So that's probably cool for questions. Anyone else?
Surely you have a question, Sharon. Sharon's an ecologist at USC as well.
No, I'm just fascinated by the knowledge you have for the area, and so it was fabulous. Thank you for sharing that.
Thank you. Really appreciate it.
Well, I've got a million questions, as always.
Uh-oh.
they're good questions. Amazing talk. It was very fascinating. And it was very in-depth and detailed considering you only started this year.
Yeah.
Yeah, it feels like sounds like you're a lot way into your project than when normal people are, I guess. So you mentioned there was a couple biases in your field surveys. Are you going to try to account for those biases in any way to try and just have in fisheries they call it CPUE, catch per unit effort, to try and standardize the sampling method across your whole survey to bring about more unbiased results. Are you going to try that in any way?
Definitely. We flagged this at a workshop that we had with Noosa Council, and we were just like, all of your species sightings are kind of in urban areas where people are most likely doing surveys.